And now to consider some quadratic equations, that is to say equations in which our variable has been squared. So we like to get x by itself, right? Well, so far we do at least have the variable on its own on the left, but it's not in its purest form, right? It is squared, yes? Now, to undo squaring, we like to say we just take the square root, yes? That's true, but not the full story, okay? So it's important to note that, we take the square root, that is only going to give us the positive number, which, when squared, would give us 16, okay? So when I take the square root of both sides of this equation, I'm actually not getting the full picture, because while this ostensibly would give us x equals 4, there's another solution to this original equation, namely x equals negative 4. All right, so this radical sign could be said to give what we call the principal square root, the positive square root. All right. Now, practically speaking, this won't be a problem for us, since most of the time we're working with geometrical quantities, and you can't really have a negative length or something like that. So it works out just fine. So this set here decently represents the kinds of situations you can run into. All right. So this first one is like our previous example there. We simply take the principal square root of both sides. And since 9 is a perfect square, we get a nice whole number. The next situation I'd like to consider here is this: if we're dealing with a fraction. All right. This is so if I take the square root of both sides, now we could put this into our calculators, right, and get a number that way. But it's important to be able to work with these things to some extent. The square root of a fraction is the fraction of the square roots, and that can all be shown from using exponent rules and so forth, if you like. And from here, then, we can use our knowledge of perfect squares to see that the answer is 1/2. All right. So y equals 1/2. Again, that's the principal square root. For this next one, I would say probably the best way to recognize the solution, not using a calculator, would be to note that this is 1/100th, which would be 1/10 times 1/10, right? So that would be that. And then finally, we come to the situation where there is no tidy, whole number answer to this, and we'll use the calculator's ability to give us an interpolation, as we call it. The perfect squares are all tabulated, and then the calculator has a nice gentle curve given for filling in the gaps. And that's actually an approximation, since it's actually an irrational number and the number goes on and on. As a side note on this topic here, sometimes it's valuable to leave something that we can't write succinctly in our decimal system. It's worthwhile to keep it in this radical form, since that's actually more precise, that's exact, whereas this is always going to be an approximation.